Hello Nickelodeons, welcome back to my YouTube channel, and this is part 3 of my muscle growth series. So as promised, I will be explaining to you the importance of muscle tension and metabolic stress on hypertrophy. There it is. Let me start with muscle tension. Now in part 2, I explained the importance of muscle damage. Now, you want to choose a load that's really heavy. You want your brain to recruit as many motor units or as many muscle fibers as possible so that you can damage them and repair. Now, a lot of studies have shown that the eccentric portion, or the lengthening of the muscle or the lowering of the weight, contributes to much of that process. Let me make an illustration here on what really happens. So this is a cross-section area of the muscle, and we have myofibres here. Now, the body's response when you get muscle damage here, you remember when there's muscle damage, activation of satellite cells, and they detonate their mRNA. So what happens is they increase the number of sarcomeres in parallel, or myofibrils. So if this is the muscle membrane and these are the myofibrils, they increase in number so that they can handle heavier loads in the future. So it becomes bigger and stronger. So what do we call that? That is called myofibrillar hypertrophy. Also called functional hypertrophy, since it didn't just get bigger, it also gets stronger. So typically in myofibrillar hypertrophy, the muscles are like denser. These are very common in powerlifters, since typically use the rep ranges around 1 to 6. Low in volume but very heavy in intensity or weight. So that's very easy to understand. Now let's move on to metabolic stress. Now, what is metabolic stress? Metabolic stress is what happens in the muscle or the muscle cell when we perform lots of exercises, usually using the anaerobic glycolysis energy system, or in books it is explained as doing exercises from 15 to 120 seconds. For simplicity, let's just say in the hypertrophy range, or 8 to 12 reps. When we exercise, there is a buildup of byproducts which are like lactate or hydrogen ions inside the... Okay, let me make another drawing here. So this is the cross-section of the muscle fiber. Now, what happens is, inside the sarcoplasm or the cell membrane, there is a buildup of metabolites like lactate and hydrogen ions. There is a migration of extracellular water inside the cell membrane or the sarcoplasm. Okay, so extracellular fluid. I'm not sure if you can read that. Now, why is the water going inside the cell? If you still remember the definition of osmosis, it is the diffusion of water molecules from an area of lower concentration to an area of higher concentration. Now, since there is a higher concentration of metabolites inside the cell membrane, the body always tries to keep homeostasis, so it draws in water inside the cell, thus causing muscle swelling. So it swells. More water inside this becomes, it stretches. Okay, so they stretch where we experience the pump, the temporary enlargement of the muscles itself. Now, why does it cause hypertrophy, or why does the muscle get bigger that way if it's just temporary? Now, remember when I said it gets stretched to its limits, diba? The body perceives that as a threat because the body does not want the integrity of the muscle, to be damaged. So what happens? It activates the satellite cells again. Okay, so activation of the satellite cells and then donation. So there will be protein synthesis in the muscle cell to make the structure stronger, to be able to handle more, loads of water coming into the cell. It's what we call sarcoplasmic hypertrophy. Sarcoplasmic hypertrophy is the most common among bodybuilders. To achieve this, you don't have to lift as heavy as the ones for myofibrillar. You just choose a load which you're able to lift for 8 to 12 reps in the hypertrophy range. But the important thing to note in sarcoplasmic hypertrophy is you need to achieve failure in order to get the most out of it. From the discussion, you would now understand why bodybuilders are bigger but are not as stronger as powerlifters, and why powerlifters are strong but not as big as bodybuilders. But myofibrillar hypertrophy and sarcoplasmic hypertrophy are not exclusive. So even though you are training for myofibrillar hypertrophy, you can still get the benefits out of the sarcoplasmic hypertrophy and vice versa. Thank you for watching this video, guys. I hope you've learned something. It's very simple, but it was very challenging for me to film. It took me a lot of cuts because I was trying to explain it as simple and as organized as possible. Again, don't forget to like and subscribe. Watch out for the rest of the series.